Hello, grade 11s. In today's lesson, we're going to be looking at vectors in 2D, resolving of vectors. Starting with the definitions, we have vector. A vector is a physical quantity that has both magnitude and direction. A resultant vector is a single vector that has the same effect as two or more vectors added together. And what do we mean by forces in equilibrium? This is when the resultant of the forces is equal to 0. Now let's look at this. We have vectors in the same direction add to form a bigger resultant vector. So in this case, we can see that we have our 8 Newton to the right and 5 Newton to the right. So calculating our F net, we're going to have F net is equals to 8 plus 5. So the 8 plus 5 gives us 13 Newton. But to which direction? To the right. So we can see that the two vectors have added to give us a bigger resultant vector. Now let's have a look at this one. It says vectors in opposite directions subtract to give a smaller resultant vector in the direction of the bigger vector. So in this case, we can see that we have our 8 Newton to the right and our 5 Newton to the left. That means we have to indicate which one is the positive direction and which one is the negative direction. So we're going to choose right as the positive direction and left as the negative direction. How do we then get our F net? We say F net is equals to 8 plus negative 5. So your 8 plus negative 5, this is how we have them subtracting now. Your positive and your negatives gives us a negative, so it's 8 minus 5, and it gives us 3 Newton. But to which direction? We always take the direction of the bigger vector. So it's to the right. Nice one. Now let's move along. Now we have vectors of equal magnitude acting in opposite directions will cancel out. That means they will give a 0 resultant vector. So let's look at this. Now we can see that they're acting in opposite directions. So let's choose right as our positive direction and left as our negative direction. Now how do we then get our F net? So we say F net is equals to 5 plus negative 5. So what is your 5 plus negative 5? This is how they will cancel out. Now you have 5 minus 5. Then that gives us 0 newtons. So there is no need to indicate the direction here. This is 0. It's not going anywhere. It's not going to the left or right. They have cancelled out. Now what about if the vectors act at an angle? They say if vectors act at an angle, we resolve them into their two components, i.e. the horizontal component and the vertical component. So we can see here that this one is diagonal, it is acted at an angle. Now we do not use diagonal forces, hence we resolve into components. So the only forces that we need are the ones that are moving horizontally and the ones that are moving vertically. So that's why we need to resolve that one. Now the quickest way to resolve this one is, let's start with the horizontal. Now horizontal means it's either going to the left or right. Now how do you think of this? You look at the one that is diagonal and you ask yourself a question. Is it going to the right or left? So we can see that the arrow is obviously going to the right. So that means our horizontal component fx is going to go horizontally like that. So that's fx. Now let's check for the vertical component. You ask yourself, where is this force moving? Is it moving up or down? So it's obviously moving up, and in that way you have your vertical component fy. So that's how you go about it. Now let's move along. This is another way to think of resolving components with your number line. So your forces will either go in one of these four directions. So if your forces are acted at an angle, they will be diagonal like that and go in either of these four directions. Now if they move this way, how do you resolve your components? This becomes your fx, because where is it moving in terms of horizontal movement? To the left. And where is it moving in terms of vertical movement? Upward. So that becomes your fy. Now what about the green one below here? Where is it going in terms of your horizontal movement? It is also going to the left. So this becomes your fx. But where is it going in terms of your vertical movement? Is it up or down? It's going down. So this becomes your fy. Now let's look at the yellow one. Where is it moving in terms of your horizontal movement? Is it to the left or right? So we can see it's obviously going to the right. So that becomes your fx. In terms of your vertical movement, is it going up or down? So it is pointing downwards. So this becomes your fy. And that's how you resolve your components. Okay, let's move along. Now, after resolving your components, you have to obviously find the magnitudes of your components. Now remember, we're not going to use this 50n because we are not dealing with our diagonal, your diagonal vectors. We want either your vertical or your horizontal vector. So this becomes your fy, this becomes your fx. Now how do we find the magnitudes of your components? So for fx, you need to know this formula. So you memorize this formula. That's f cos theta. I don't think it appears in your formula sheet, so you have to know it. So, and your fy is f sine theta. So for fx, when you're looking for the horizontal component, that's f cos theta. When you're looking for your vertical component, that's fy sine theta. Now, what is your f? What is this f for? The f is for the force that you've been provided with here. So your f cos theta, for your f, you put the force that you've been provided with. And for your theta, you put the angle that you've been provided with. So now you have to note one thing about the angle. The angle must always be on the x-axis to the resultant vector here, or the vector that has been acted at an angle. So if it's here, let's say we had 60 here, you have to note that we do not use the angle that is in between the y-axis and the resultant. So always it must come from the x-axis. So if it's here, what do? You say 90, because the whole angle here is 90 degrees. So you need to say 90 minus the angle that's in here, then you get the right angle there. So always note that, excuse the pun for right angle. So it's, what I mean is the correct angle. Then, okay, let's move along. To calculate your fx, that's f cos theta. Then what do we put for your f? The force that you've been provided with, the magnitude, that's 50. Then cos, your angle is 30 degrees. Then you just punch that in your calculator. You have 43.30 Newton. And where is it going? Do not forget to give the direction. Remember, this is a vector. Vector is where we have both magnitude and direction. So if you don't put the direction, you're simply saying this is a scalar. Then fy, we have f sine theta. So now we're calculating the vertical component. So what is your f? That's 50. And then we have sine, the angle is 30 degrees. You punch that in your calculator, you have 25 Newton. And what's the direction? Upwards. So now that's how you calculate the components. Now let's calculate the resultant and see if we're going to get that 50 that we've been provided with. So now, how do we calculate the F net. Remember, on the other ones, we were only looking at forces that are in like one dimension. So that's why they were moving in just one direction. So with that one, you can just add. But then now these are vectors in two dimensions, meaning you cannot just add like that. You need to now use the Pythagoras theorem, because if it's going that way, your Fy, and this is your Fx moving that way. Now to get your F net, you need to draw this here. And now you can see that this becomes a right angle triangle. So you're gonna get your F net as your hypotenuse side. So when solving your F net for two-dimension vectors, always know that you will use Pythagoras theorem. So it goes Fx squared plus Fy squared. And what's your Fx? We had 43.30 square plus 25 square. Then you punch that in your calculator, you have 49.998, which if you just round this off, you're going to have 50 newtons. Correct. Now let's say they wanted the direction. How are we going to get the direction? So remember, now you have your right angle triangle like this. That's your Fy, that's your Fx. So if we put our angle here, now you can see that the trig ratio that we have to use, if we have that information, is what? What do we have here is the adjacent side, and what do we have here is the opposite side. What trig ratio allows for that? That's tan, using your SOHCAHTOA. So that's opposite of adjacent. So every time we're looking for the angle, we use that. So the angle determines our direction in terms of the bearing. So that's your Fy over Fx. Now let's calculate. We have tan theta is equal to Fy over your Fx. What is the Fy? It's 25. And then what is the Fx? 43.30. Now when calculating this one, you now have to say theta is equal to tan arctan. Then you say 25 over, so that's 25 okay, let's do it here. You have tan theta equal to Fy over Fx. Said our Fy is 25, then we have 43.30. Then our theta, you say arc tan, then we have 25 over 43.30. Then your theta becomes, so if you punch that in your calculator, it must give you the 30 degrees that we were provided with. So 30 degrees, that's your solution. And we are done.